Let's say you're me and you're in physics class, and your teacher asks you to look at the data that you collected in lab 2. They say, if we look at the slope values and the force and the net force values, they're very similar. Let's think about this for a second. If there was no friction on the track, how would that affect these results? You realize that the only thing to change would be the rate of acceleration, because friction opposes motion and acceleration is a measurement of change in motion. Without friction slowing the cart down, the rate of acceleration would increase. This means that the slope value would increase, and thusly it's fair to say that without friction the slope value would be equal to net force. Let's put that into an equation format. The slope of the line of best fit for this graph is the change in vertical axis over change in horizontal axis, or acceleration over inverse mass of the system. This can be written as meters per second squared over 1 over kilograms. We can add equal to newtons because, as we just figured out, with no friction, the slope is equal to the net force. Let's simplify this so it's no longer a complex fraction. By multiplying by the reciprocal of the denominator of the complex fraction, we can get rid of the large division bar and simply multiply, leaving us with meters times kilograms over seconds squared is equal to newtons. Now that we have that equation, let's take a look at the data collected from Lab 1. The slope was acceleration over net force. This can be written as meters per second squared over newtons. Let's look back at the equation we just wrote, which stated that mass of a system times the rate of acceleration is equal to the net force of that system. We can substitute kilograms times meters over second squared for newtons because they're equal, giving us meters per second squared over kilograms times meters per second squared. We can cancel out the meters per second squared, and you're left with 1 over kilograms. So that can be written as meters per second squared over newtons is equal to 1 over kilograms. This reminds me of something, the previous equation. In the first equation, we multiply both sides of the equation by the opposite of 1 kilogram, precisely 1 over kilogram, to isolate acceleration, and we're left with meters per second squared is equal to newtons over kilograms. For the second equation, we multiply both sides of the equation by newtons to once again isolate meters per second squared, and we are left with meters per second squared is equal to newtons over kilograms. With a few simple tweaks, we see that they are the same. Acceleration is equal to net force divided by mass. We can also see this relationship by looking at the original slopes from the lines of each lab. The second lab shows that the mass has an inverse relationship with acceleration, and from the first lab we see that net force has a directly proportional relationship with acceleration. Who would have thought we could have figured this all out while just sitting in physics class?